Okay, so as I told you, today we'll be starting with Orange tool. So Orange is actually an open source tool that was invented way back in February 2020. I'm sorry, like even more than that. Okay, so before we start, I'll tell you as how to download that Orange tool. It's pretty straightforward. You just give it as Orange tool. Okay, so the first thing that you get is the link. Oh, 1 second, I'll share my screen. Okay, so hope you can see my screens now. So this is how you download and install the Orange tool first of all. So here is the first link, orangedataMining.com. Don't feel that I'm going to teach you a data mining tool today. Like in fact, this is a data science tool because in every version they've been adding so many add-ons, and by now we have all the neural networks and so many other features to this Orange tool. So although it started off as a data mining tool, right now this Orange has emerged out to be a data science tool. Okay, so that's why I'll be discussing this today. So click on the first link, orangedataMining.com, and you have this download Orange option right here. Click on that, and this could be installed in your Windows or Mac OS or Linux versions. OS, anything. Okay, and of course most of you would be using this Windows, and I tried only with the Windows. So if anyone wants to try it with Mac OS, feel free to do it. And if you have any queries, you could ping me in MS Teams. Okay, so if you want to download the latest version, just click on download Orange 3.32.0. Or if not, if you want to go for any older versions, because mostly the recent versions will not have much of support. But then this 3.32 is had been long for so long. So you have enough support for all your queries. So you can very confidently download and install this. Okay, or if not, if you want to go for any specific version, go down and then you have this archive folder where you can find all the previous versions and all. Okay, but then the very recent one is always the best choice to use. So just click on the download button, and it's like pretty simple, just like giving next, 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 you could be able to install the Orange file. Okay, so since I've already installed it in my system, I cannot do it again. But if you want, maybe like after the session, I'll uninstall it in my system and I'll redo it again. Maybe I'll put it in a video. You can refer to it. Okay. So this is how you basically download and install the Orange tool. And if I have to tell you about what Orange is, as I told you, it's a powerful data analytic platform. So where you can load data, visualize data, make some channels like between one thing to another thing, make some analysis, clustering, classification, and a lot more. Okay, and this is purely codeless tool where you don't need to know anything. Python, R, no languages are required. It's pretty simple. It's just a drag and drop. Okay, so with a simple drag and drop, today we'll be seeing many interesting applications, although all will be very trivial applications only. Like we'll not complicate things as we are in a learning mode. We'll use the basic iris and wine and housing data sets to learn and build models. Okay, so later on we can do some projects, interesting projects with a bigger data sets. Fine. So this is how Orange tool basically looks like. So if you could see when you click on the Orange tool, okay, so when you click on the Orange tool, the first thing that pops up is the welcome screen. So you could see the welcome screen here. Of course, as usual, it shows you the option to open a new workspace or open the recently opened ones. And of course, there's many video tutorials which will take you to YouTube link, and there are many examples, documentations, and lot more. Okay, so this, of course, we are not going to see it right now. Just close it off. At your free time, if you want, you can go through these videos and examples. Okay. But then today I'll be starting off with very basic things required for building a small project. Fine. Okay. And now the thing that you see here, we say it as a white canvas. It's a blank canvas actually. And here, this side to the left, we have the widgets. Okay. So these are all each one small things is called as a widget. And what is a widget means? Widget is basically a small component in the Orange, which is used for uh, which is used for certain functionalities. Okay. Now, as you could see, the first one is a file widget. So it basically will ask you to load a file. Okay. And if you want to load a CSV file, it's CSV widget. If you want to load a big data set, then it's data set widget. If you want to view a table, then it's data table. Okay, so each of the widget is a small component which has specific functionalities. Okay, this orange is entirely dependent on the widgets only. And once you know what each widget will do, you can master the orange tool like anything, like a pro. Okay, so the first one is like data widget, which has these components: file component, data table, paint data, data info, rank. Okay, like I cannot be explaining each of the things right now, but as and when we do each samples, each problems, I'll tell you what each is. Okay, so let's not try to understand each of the widgets right now. And the second widget we have is under the transform, which will help you to transform your data to a new format. Okay, so data sampler to select a certain columns, merge data, aggregate data, and so many more. Okay, and you could see the third one is a visualize. So of course, you know how to visualize your data. You need bars, charts, graphs, and all. So we have scatter plot, line plot, box plot, and so much more to view your data. And then it's about the modeling, like how to model your data. Like we have various options, like starting from basic classifier like KNN, SVM, to very recent ones like neural networks. We have so much more. AdaBoost, Navy Base, logistic regression, linear regression. These are the different models that are supported by Orange. Okay. And going down, you have the evaluate option, by which you will be able to test your model and then understand how the model has performed on the given data set with a given algorithm. Okay, so the first one is test and score, which will tell you the table that is required. Like when you build a model, of course, as in your projects and all, when you build a project, no, the end result should be represented in terms of accuracy, precision, recall, AUC, a lot more. Right, so all those values will come under test and score. And of course, you have this confusion matrix to tell you which all are correctly classified and which all are like incorrectly classified, and lot more. This comes under evaluating your model. Going down further, we have unsupervised unsupervised algorithms like distance matrix, correlation, clustering, k-means, and lot more. Okay, and then two major interesting add-ons are like image analytics, where you could build very interesting image-based applications like image classification, image clustering, and lot more. Okay, and you have these 5 simple widgets for image analytics. And the final thing is like text mining. So if you want to work on any NLP related projects like what to say, like sentimental analysis and lot more, you can use this text mining widget. Okay, so these are the rough idea of what each widget is right now. Like you see, we have data, transform, visualize, model, evaluate, unsupervised image analytics, and text mining. Okay. Apart from this, you have even lot more. Like when you click on the options button here on top, you get this add-ons. So when you click on the add-ons, it will tell you the list of packages that's available. Right now, I have installed only the image analytics and text. If you want to work on anything related to bioinformatics, education, geoscience, lot more, you can just click on that and then install it. Okay, just by clicking on that, it's more than enough. Just give OK and it will install that particular package in your system. Okay, and once it is installed, it is recommended to reopen the Orange tool. Okay, so every time you install a new package, you need to close the Orange tool and open up in a new window. Okay, so this is how the Orange tool basically works. Apart from this, you have the basic menus like file, where you can open a new file, save as. That's more than enough to understand. Save your file using save as option. And then you have this, nothing much. Okay, these are all like not much necessary. One thing that you need to understand is we have add-ons to add other packages as well. Okay, so this is all about it. So we'll start with a very basic program, like problem. Let's try to load a small data set and visualize it. Okay, so this is the first thing that we'll be attempting to do. So like if you feel that this space is not enough, then you can click on this button and then close it out there. Or if you want, you can just click it. Okay, so basically like right now for this first exercise, we'll keep this on because I want to drag and drop the widgets here. Okay, so now what I said you was like the first thing that we'll be clicking on. Okay, right now I'm clicking on the text annotation at the bottom so that I give a name for my program here. Okay, so loading a data set, loading, and Visualizing a data set. This is what we are going to do it right now. Okay. And Orange works by drag and drop method. Okay. So if you want to create a new file, click on this file, drag and drop it here. Okay. That's one way. Or if you just click on that file, that's more than enough. Okay. That's another way. Or you can just right click and then type file. It gets loaded here. Okay. These are the different ways how you could bring a widget to the canvas. So I use this drag and drop method here. Okay. So this is the file. And when you click on the file, you have to load a particular data set. Okay, just click on that. And as you could see, there's a browse button here. Click on browse. These are the inbuilt data sets we have with Orange. The brown selected tab, heart disease, housing, iris, Titanic, and zoo. As I told you, we'll start with a pretty simple iris data set. I think most of you would be pretty clear with what is an iris data set is. So it's basically a flower species classification where you have three different types of flowers like setosa, versicolor, and virginica. Okay, and these three species of iris flower are categorized based on their sepal length, sepal width, petal length, and petal width. Okay, right now our data set is loaded here, iris.tab. Okay, and one other thing I want to tell you is CS Orange supports only three types of files. Like one is Excel sheet, CSV, and then tab files. Okay, these three are the things like pretty much only these three things a file can support, Orange file can support. Apart from that, you can load a large, big image data sets and all. But when it comes to text files, all that it supports is text file, Excel sheet, CSV, tab. Okay, so we have loaded the data set and you can see the contents of the data set right here. Okay, sepal length, sepal width, petal width are its four features. And the three classes are setosa, versicolor, virginica. Okay, it's given right here. Okay, now close this. Now I know that there is some file in my data. Okay, there's some data loaded in my file. If I want to view this file, all that I have to do is click on the data table here, right here. Okay, you could see it on the left side. Click on that and drag it over here. And then now when you click on the data table, it's like all empty. Okay, because there is no connection between the file and the data table. All that you have to do is click on the file, drag a line, and then connect it with data table. Now there is a connection. This connection is nothing but a flow which will pass all the inputs from the file to the data table. Okay, now all the data are being passed here. Now when you click on the data table, you can see the whole data set here. Okay, so this is what the data set looks like. As I told you, sepal length, sepal width, petal length, and petal width. And apart from that, we have these three types like iris setosa going down. This green, red color represents iris versicolor, green color represents iris virginica. Okay, so these many data sets you have, if you want to know the character, the details of your table, it's given right on top here. Like on the left top, you could see there's 150 instances and there's four features like sepal length, sepal width, petal width. And the target is like three values, setosa, versicolor, and virginica. And there's no metadata available and there's no missing data as well. Okay, so we have 150 rows here and four columns. Fine. So this is how your data set looks like. Okay. Now by clicking on the file, you can load any data set, and by clicking on data table and by connecting with a line, you can view the data table in a like in a tabular format. Okay, so this is what it is. Apart from that, if you want to understand how the data has been distributed, okay, if you want to understand the different values or like something like a histogram, if you want to view that, then we have something else called as distribution. Now, I cannot go and search for where the distribution widget is every time, okay, because it's not in data. Let me move to the next one, transform. Okay, so the distribution is not right here as well. Okay, so like this is bit tedious every time to search it in the widgets box. So what we could do is just right click. Okay, just right click. Okay, just right click on that and then type distribution here. Distribution. Okay, so the widget comes up. You could just click on that and the distribution comes up here. Fine. So this is how you can search. So now you understand that this is not necessary to keep this open. We can close it off because every time when you want a particular widget, just right click and then search the name that you want. This is file or this is data table. That way you can search. So this is much pretty easier than by using these and all. Okay. So close that. And this is our distributions. Now what I'm going to do is like I'm going to collect the file with the distributions so that there's the data flow there. And then when you click on that, you could understand how the values are. Okay, like let's understand one particular thing. Let's take this blue color stands for this iris setosa, and then like it's in. Okay, so it's like in the range of 0 to 50. There's a lot more that you can understand. Like this is more of like a histogram, as I told you. Just understanding how the datas are distributed. Okay, let's take one particular example. The red color stands for iris versicolor. Okay, and as you could see, this one is like the sepal width. Okay, which means around like this is the frequency. So around 10% of the data has the sepal width of iris versicolor in the range of 2 to 2.2. Okay, that's what this particular chart means. Okay, only this particular bar represents the sepal width in the range of 2 to 2.2, and the frequency is like for 10. Okay, like as I told you, there were like around 150 rows, out of which 10% has the sepal width in the range of 2 to 2.2. Okay, this is how you have to infer the rest all as well. Okay, the same way you can infer the data for petal width, petal length, sepal length. Okay, so this is about understanding how the data is distributed on what ranges. Okay, or if you consider a simple student database, and if you want to know how many people are in the age group of 70 to 20, or how many first years are in the age group of 70 to 20, you could use this distributions to understand the actual frequency, the actual count. Okay, so this is what the distributions is. Fine. So, and if you want to view it like like if you don't want it this way, or if you want to view the table, view the file in a chart format, then you can go for scatter plots. Okay, so let's take one other thing. Okay, just click and then type scatter plot. It comes up. Okay, as you could see, I'm dragging it so that so that my workflow looks a bit neat. Okay, so I'm just connecting the scatter plot. And when you click on the scatter plot, so this is how the data are scattered. Okay, or how they had been clustered. Okay, so if you feel that this is not a really good cluster, and if you want to find it in a different way, you can very well change the axis from X and Y. Okay, so right now the X axis represents the petal width and the y-axis represents the sepal width length. Okay, maybe let's change it to petal length. Okay, and now the clusters are this way. Okay, or if I want to change the x-axis to sepal length, again this is like this way. But every time you cannot take a snapshot of this and then compare which one gives you a better clustering, better projection. So you could do one thing, just click on the find informative projections. Okay, as you could see here on the left side, top left, there's one thing called find informative projections. Okay, so this is that. So all you could do is like just click on that. There's a start button here, if you could see. So click on the start button and then it will tell you all the combinations like petal length, petal width, and what is the value for petal width and sepal length and sepal width, so much more. Okay, these are the different combinations. Now just click on each of the things. You see this is not a very good cluster because so many data are like mixed up. Okay, just type with another thing. Okay, this is much better than the previous. The other thing, other and other. Okay, so of all this seems to be, I mean, when petal length and petal width are considered in X and Y axis, it seems to be much better, right? So this is how, okay, so this is how you can check with the different options available. Fine. So this is a way to view your data. And if you want only to view a certain thing, let's consider I don't want to see any blue color. I want to see only this particular portion. You can select it. Okay. You can see the difference, right? All the selected points are highlighted with a yellow circle. Okay. So this is how I can select a particular thing. Now go back to the scatter plot and then connect it as data table. Okay, now when you click on the data table, you could see only that combined things. Okay, so you could see that this is a scatter plot actually. I have not taken any blue colors. So my data table does not show any blue color things. Okay, you could see it, right? Only red and greens. Or if you go back and select only the blue color things, now the data table would be reflected. Okay, now you see only the blue color things are reflecting. Fine. So this is a way how you can select the particular data. Every time you change something here. So right now I'm changing only the green color and now our data table gets reflected with all the green color values alone. Okay. So this is how you can do it. So you can select a subset of data and then you can view it. Okay. Right. If you want to view only the blue color, which represents the iris setosa, then you can select and then view the corresponding table and corresponding values. Okay, so all this belongs to a group one, like one particular group, and these are its particular values. Fine. So this is how it is, and this is a first exercise. Okay, let me tell you once again because this is the first time. So if you want to load a data set, you have to use the file widget. Click on the file widget, browse and select whatever data set you want. I've taken this iris data set. Okay, immediately after loading the data set, if you want to view your data table, you have to use this data table widget. When you click on the data table, it will list you all the entire data set. Okay, the entire values are listed here. Okay, and the detail of your data set is given on the left top. 150 instances, 4 features, 3 values, and no meta attributes. Fine. And every time without a connection, it's not going to tell you. See, now the data table is empty. So Orange works on the basis of connections. Okay, so unless and until you give a connection between two widgets, it's not going to work. Okay, so this is what the data table is. On the other hand, if you want to understand certain characteristics of your data, how the data has been distributed, you can use the distributions widget, which will tell you like different things. As I was telling you, if you want to understand the list of students in the range of 17 to 20, or the list of students who got CGP above 9%, all that kind of distributions you can understand with the distribution widget. And the same data set, if you want to view it visually, you can use the scatter plot. And of course, the scatter plot can vary based on the X and Y axis. To find the best choice, click on the informative projections right here and you have the different options available. And which one segregates, like at the end, the scatter plot should tell you a clear distinction between each of the classes, right? So you can choose which one seems to be the best. Fine. So that's that one thing. And if you want to display only a selected values, then maybe you can click on that particular things in the scatter plot. And then again, if you want to view it as a table, of course, you have to give it as a data table. Again, give a connection and your data table will list out all that things that's in blue color only. Okay, so this is the very first thing. So this is about loading and visualizing a data. I'll give you a quick 1 minute time. So if you have any questions on this, please put it in the chat box. If not, we'll move to the next exercise. Any questions? Yeah, Meghna.
No, ma'am.
What does iris setosa, iris versicolor,
Yeah.
iris virginic, all these useful for what reason, ma'am?
Okay, fine. Okay, I thought you would understand what the data set is. Actually, this is basically a flower type classification. So wherein like iris is one particular flower which has three different species. Okay, you could see this figure, no? This iris versicolor is one type of flower, setosa is another type, virginica is another type. So as you could see in this figure, everything looks almost same. The color, everything is like almost same only, but it differs on a simple thing. You could see the petal is different for each of the thing and the sepal. Okay, so we are calculating four features. What is the petal length? What is the petal width? What is the sepal length? And what is the sepal width? Using these four features, we are trying to classify the iris species. Okay, so that's what this particular data set is. As you could see here, data table. So you see these are the four things. Iris setosa, what is its sepal length, sepal width, petal length, petal width. So those values are actually given. Now using these values, you need to classify if the given species is a setosa or versicolor or virginica. So that's what it is. Or in simple terms, if I tell you, you can take any other data set as well. You will of course have like if I take an animal data set, you will have like different species like cat, dog, cow. And how do you classify them? Of course, you can take different features like the animal's texture, the animal's height, the animal's weight. Lot many features can be taken, right? Likewise, these are the features taken for a particular species called iris. Okay, and based on that only we are trying to understand how setosa looks like, how virginica looks like, and how versicolor looks like. Okay, so like this is just for that iris data set. Apart from that, like this, like I just want you to understand how to load a data set, how to view it, and how to use the scatter plot. Now you see this, no? Like this is how the data are segregated. So this particular graph says whenever the petal width, as you could see at the bottom, whenever the petal width is in the range of 0.2 to 0.8, the possibility that the flower is setosa. The same way, whenever the petal width is in the range of 1.1 to 1.6, it could be versicolor. And when it is like 1.8 to 2.4, then it could be virginica. Okay, so this is a way of classification. Fine.
Can say about the 360 degrees era of the whole information we need by these classifications.
Sorry, come again, please.
We can say this is the it is a particular information which we get on whole the 360 degrees we will be visualizing in this orange.
Exactly, exactly. Okay, like someone actually gave the data set for that iris. Actually, these values that I've shown you, right? This is already given by someone. Okay, they have measured, like you could see setosa 50 samples they would have taken. Similarly, versicolor 50 samples, virginica 50 samples. They literally measured the length of the sepal, width, petal and petal one, and they gave us this data set. Now, what we are going to do is just load it and visualize it. And from that, we are just trying to take a 151th sample, which could be any of the three things. Okay, it could be like any of the three things. And then we are trying to find if it is like versicolor, setosa, virginica. That's the ultimate aim. And in this exercise, I've just told you as how to load the data set and view the data set. That's it. Okay.
Okay, ma'am. Thank you.
Yeah. Any other questions? Okay, fine. So in that case, we'll move to the next exercise. Okay, we'll close all this. And now I'm going to save this exercise so that I'll share it with you. So just go to File, Save As option, and then I'll give it as today's date is July 1. And my first data set is, sorry, my first file is Load and Visualize. Okay, and as you could see, the orange files get stored in the name of OWS, which stands for Orange Workflows. Okay, so that's how I saved it. Fine. Now I'm going to open a new file so that we start with the next exercise. Let me close the old one. Okay, now this is a empty canvas again. Okay, now in this, the second exercise that we would be seeing is something similar to the previous one, but then like a bit different. Okay, so before that, I want to remind you of the ways you could drag the widgets here. The first option is just click on the file that will pop up the file in the canvas, or drag and drop. That's the second option. Or the third option is click on the right click and then click on that, type the name and you would get the file name. Okay, so these are the different ways. Fine. And I'll be predominantly using the type option. Okay, I'll just right click and then type file. That's how I'm going to use it right now. Okay, so okay, fine. So the next thing that you would be seeing is how to load a data set that you create. Okay, so the first time that we saw is like we just use the data set that is available in Orange. So right now we are going to see a new data set that you will be creating, and you want to understand how the data set is. Okay, and as you know, you have different ways to create a data set. The first and most simplest thing that we would follow is using an Excel sheet. Okay, you would literally open up an Excel sheet and then start typing what the content of the data is, like name, gender, age, and lot more. And you would start typing, save the file, and then load the file there. Okay, that's one thing that's pretty simple. So I'm not following that technique. Let's go for some other technique called like using the URL. Okay, I hope you might be familiar with Google Sheets. So we'll use a Google Sheets. Just write Google Sheets, click on the first link, go to Sheets directly. Okay, this option. Now click on blank sheet. Fine. Okay, now this is how my Google Sheet looks like. Now right here, I'm going to enter my data set. Now what the problem I'm going to consider is based on a person's based on a person's height, weight, and eye color and hair color. Okay, these are the four features. What is it like height, weight, and then eye color and hair color. Based on these four features, we are going to predict if the given values belongs to a male or female. Okay, and of course we'll have one other value as name, which is like a meta information, which is not necessary because you cannot predict if a particular person is a male or female based on the name. Okay, because we'll not take that easy technique. Okay, we'll consider the height of a person, weight of a person, eye color, and hair color to predict to guess if the given person is a male or female. Okay, so we need to enter certain values here. So like I've already typed it, maybe I'll copy it from there. Okay, so these are the values that we have. Okay, so this is how my data set looks like right now. So we have height of a person, weight of a person, eye color, hair color, name of a person, and then gender. Okay, these values we have typed it now. Okay, this is the column and representing the uh, attribute name. Fine. Below that we have different values. Okay, so okay, so this is the whole data set that we have. So from this, we are going to predict if the given person is a male or female. Okay. Now, if you want to load this data set, to Orange, all that you have to do is click on the share icon and then give a name for this. Okay. So gender prediction is the name of the file that I have. Fine. When you save it, you get the option for copying link. Before that, click on anyone with this link. Okay, this is all up to you. Now I'm going to copy the link of this Google Sheet. Copy link. Okay, done. Now going back to the Orange file, what we have to do, the first thing we have to load is the file widget. Okay, and right now when you click on the file widget, if you have any data set already available, you can click on the browse and then click. But this time we are going to use the URL. Okay, so click on the URL icon and then type the link of the URL there. Okay, so now this is the URL we have. Fine. So, and when you see that the file got loaded there, as you could see the height, weight, eye color, hair color, gender, name, everything got loaded. Okay. Now the same thing, if you want to view this file like in a data table, then you have to do, what you have to do is like connect it with a data table. Okay. So I've connected with the data table so that I can view my data set as a table format. Okay. When you click on that, you see that we have this name, height, weight, eye color, hair color, gender. Everything is given. But then, unfortunately, we don't understand which one is taken as a predictor variable. Okay, what I told you, we have to predict the gender actually. Okay, so if you want to check on all that, one option that you have is select column. Okay, so click on the select column and then connect it with the file that you have. So now when you click on the select column, you could see it right here, right? So these are the four features that we have: height, weight, eye color, hair color. And what is our target? Our target is to predict if the person is a male or female. So gender is the target variable. And what is a meta? Meta is something, some extra informations. Okay. Name is the extra information that we have. However, we are not going to consider the name while we are doing the analysis. We are going to basically make the analysis if a person is male or female based on these four values only. Okay. And now this is how you understand your feature set. Okay. To understand your feature set, we have used the select column function. At sometimes when your data set is not properly written, it tends to take a wrong variable as a target. Okay. Now in this case, what I have done, the target is height, which means the ultimate target is to predict the height of a person. That's not the actual problem, right? Our problem is to predict if a person is a male or female. So the target variable should be gender. So in that case, you can drag and drop. So simple. Okay. So even if that data table has taken it in a wrong sense, you could use the select column option and then see which is the target variable. Okay. And which one is the meta variable? Meta variable is something which is extra and which is not used for the prediction here. Fine. And apart from that, if you feel that I don't want to use this eye color while doing the prediction, if you feel that it's not going to make any sense, then in that case, click on the eye color and click this option. Now, this particular eye color is ignored. Okay, we are not going to consider the eye color of a person to make the gender prediction. Okay, fine. So let's have it here. But that's how you can filter out the features. This particular example has just four simple features like weight, height, eye color, and hair color. So we are not going to lose any information that we have. Suppose if you have like 1,000 features, and definitely the model will take so much time to run. Okay, all the examples that I'm showing you here is so simple. That's why it's running in no time. But in real time, when you want to run a bigger projects, all the steps are going to take a substantial amount of time. So in that case, if you don't want to have certain features, if you feel that 1,000 features is really too much and you want to take only top 50, you can filter out using this option. Click on this eye color, filter out. As you could see, these are all ignored features. Fine. And these are all considered features. Now, right now, I'm considering it here. Okay, so close it off. This is how the select column functions looks like. So this is pretty like easy one. Like if you want to fix the target variable, if you want to filter out certain variable, if you want to include certain variable, then this is how you do it. Okay, that's for select columns. Okay, and now again, if you want to view the data table, you can drag on that and then click data table. Fine, double click. And now you see that we have got the gender as a predictor class. It has come out correctly. I mean, you have to find it out with the color actually. Okay, this gray color represents the predictor variable. Gender is a predictor variable. And the meta informations are given in this khaki color. And all the rest white colors are the list of features we have. Okay, now you could see the difference between this data table and that data table. You see that, right? In this particular data table, name is properly considered as a meta variable, wherein the rest all features are considered as a normal variable. Okay. By after selecting the columns properly, now the data table looks proper. This is the predictor variable. This is the meta variable. These are all features that we have. Fine. So this is how you can load your own data set. Okay. All that we did was like go to Google Sheets, type in the data set that we want. Okay. So if you want to make an analysis of students, you can gather the students data, whatever is required, name, register number, batch, branch, CGPA, semester marks, extracurricular activities, awards, lot much more, and you can make it as an Excel sheet. From that, you can load it using this URL option. Okay, click on the URL option and then type in the link over there. Okay, and then after, if you want to view the data set, you can use the data table. Of course, there is a possibility that the data is not interrupted probably correctly. Okay, because we type the data set. So Orange may take it in a different sense. 100% it's not going to understand your data in a perfect sense, because only I know my problem is to predict the gender of a person. So if the Orange tends to take it in a wronger sense, you can rectify it using select columns option. Click on that and then you can fix it, what to consider, what not to consider, which is the target variable, which is the meta variable, and so on. And finally, your final data table looks like this. Okay, so this is our second exercise, which is nothing but loading your data set. Let's name it as creating and loading data set. Okay. So this is the second exercise that we have. Now, you know that your data set is actually stored in Google. Okay. The data set is actually stored in Google Sheet, right? So if you want to store it in your local device, this is the final data table. This is the proper table. This is not so proper, right? So this is the final table, right? So what we are going to do is drag a line and then save it. Okay. Save data. Now this is the way you can save the data. Here, click on save as option, desktop, and then gender prediction. Okay, it's going to save it, it's going to get saved as a CSV file. Okay, save. Fine. So here is a gender prediction data set that we have. Okay, so as you could see, it has given one other additional information. One second. Okay, now as you could see, this first thing is all the names, like attribute names, weight, height, eye color, everything. And these are all the values. Okay, so this is all the values that we have. Apart from this, there's two things that you could see here. That is the meta and class. Okay, which means as I told you, gender is the class that we are going to predict, the predictor class. Okay, so that is explicitly mentioned as class here. The rest all is empty, which means they are all features, and the meta information that we have is name. Okay, and it has also told about the data type. Name belongs to string data type. This weight belongs to continuous values. Okay, the same way height should also be the continuous values. The other cases should be string again. Okay, somehow, like this is how sometimes the interpretation could be wrong. Okay, so this is again a string. Fine, I'm just saving it. Okay, so when you save the data set, while we just created as the table name and the values alone. And when you saved it, you got it in a different way. Additionally, you got to know what is the type of each of the variable and which is the class variable and which is the meta variable. All these informations get stored additionally. Okay, if you don't want it, just ignore that. Okay, just delete that columns. Fine. Now the data set is properly saved in a proper format. Okay. So this is how you can actually create a data set in Google Sheets, load it here, format it in proper format using the select columns, and then finally save it using save data. Now the data gets stored in your local device. Okay, so this is the second exercise that I want to tell you. This is create and load data set. Okay, again, another 1 minute for you. So if you have any questions, you could ask. Any questions? Please raise your hands if you have any questions. Okay, so I take this as no question. So we'll move on to the next exercise, a very interesting one, which is on hierarchical clustering. Okay, we are done and dusted with how to load the data set and how to view the data set. Hope you're clear with all that. We have just seen few widgets like file, data table, select column, distribution, scatter plot. These are the simple widgets that we saw till now. Okay, now going to one interesting application called hierarchical clustering, how we are going to cluster your data set. Okay, again in this case we'll consider the iris data set, and as you know, iris data set has three classes: virginica, setosa, and versicolor. So we are going to cluster these three. Clustering means grouping these three. Okay, how you're going to group them based on their sepal length, sepal width, petal length, and petal width. Okay, as usual, the first thing that you have to start off with is using the file icon and go to file, click on the iris data set. Now we are going to using the file options. So click on the file option, click on the browse, and then there's iris data set here. Open it up. Okay, so sepal length, sepal width, petal width are the four features. Setosa, versicolor, virginica are the three classes. We are going to cluster them now. Okay, now to view the data set, of course, you know what option it is, data table. And then click on the data table. So it shows you sepal length, sepal width, petal length, and petal width. Okay, this is how the data set looks like. And as you could see, it has three classes: blue color, red color, and green color. Okay, so which means it's pretty clear that we are going to have three clusters because there's three different classes. It's obvious that we are going to have three different clusters. Okay, but then assume that you don't know how many classes are here right now. Although you know that there are three different classes, but assume if you don't know how many classes are there, then how do we calculate the clusters? How do we find a proper clustering for the given data set? Okay, the option that we have for that is distance. Okay, every time if you want to calculate a cluster, the first thing that is required is distance. Okay, so one second. Okay, let me explain what is the distance first of all. Okay, assume that okay, now these are the 4 different clusters I have. Assume this is dog, this is cat, this is cow, this is monkey. Okay, now if you want to, but you don't know, like if you have one particular, only one data set like this. Okay, let's put it this way. Okay, now you have one particular data set here, this blue color in between. Now you don't know this particular data set belongs to which class. Is it cat, dog, monkey, cow? Now to find out the actual class of this particular variable, you need to start calculating the distance between this particular variable and the classes. Okay, every time you would calculate the distance between this blue and this, and next time this blue and this, next time this blue and this particular class, this time this blue and this particular class. Every time when you calculate the distance, whichever has the least distance, and now it's like obvious that this particular thing has least distance. So this blue should belong to this particular class. Okay, so this is why we actually calculate the distance when we want to do the clustering. Okay, so when you want to know, like when there's a random person and you don't know like where to put him in, every time that you have to do is calculate the distance. Okay, how far it is closer to a particular variable. It's not so obvious as calculating the distance using a scale, but like it's bit more technical. Okay, let's not dive into all that concepts. But for now, understand, if you want to understand the clustering, you need the distance concept first. Okay, so what we're going to do is connect this file with the distance so that the data is flowing from the file widget to the distance widget. And then after calculating the distance, you need to use some of the clustering algorithm that's available. Let's consider the hierarchical clustering right here. So this is how the clustering option looks like. Now we have taken all the data, calculated the distance, and we are clustering it. The clustering that we have taken is hierarchical clustering. When you click on the hierarchical clustering, you see this is how the data is clustered. As you could see, this very small box all belongs to Virginica. There's one small versicolor there. Okay, when you click on this all belongs to Virginica and one versicolor. Okay, like it's a bit complicated to understand from this too. So what we'll do is we'll use the scatter plot as usual to view it in uh, a table. Okay, but before that, if you want to have it in a data table, you can view it. Just click on the data table. And now you see, uh, going back to the scatter plot here, we selected only these values. Virginica, 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 there's one versicolor and one Virginica again. Only some 7 to 8 values that we have taken. So that you could see it here in the data table. Okay. So the 8 values out of which one is versicolor, the rest all belongs to Virginica. Okay. So this is how you view it in a table format. And the same thing if you want to view it in a scatter plot, of course you can give scatter plot and then connect it off. Okay. Now this is for the entire data set. Okay. So for the entire data set, this is the scatter plot. Or if you want to do it only for uh, uh, the table that you have just selected, then you can give your scatter plot right here. Okay. So this way you can actually calculate the clusters. Fine. One second. Okay, so what I was telling is like this file is on Iris dataset again. To view the dataset, you have this data table option. And then now in this particular exercise, we are going to understand the concept of clustering. Okay, how it is clustered. Okay, so this is how the clustering, final clustering looks like. So on some basis, they have clustered all these things as cluster one. This is cluster one again. This is another cluster. This is another smaller cluster. And this is one whole cluster. Okay, this is how they have clustered the data. And if you want to view the particular clustering, you can use the data table. Or if you want to view it in a scatter plot, then you can use the scatter plot as well. Okay, so this is the scatter plot for the particular figure. Okay, so again, as usual, you can select a particular cluster and then you can see the scatter plot for particular thing. Okay, in that case, you need to go to that. Here I have selected the entire thing. No, right now let's select these 4 values alone and see how the scatter plot is. Okay, so going back to the scatter plot, you could see there's only 4 points, 1, 2, 3, 4, because in the hierarchical clustering, I have selected only the 4 options. Okay, the small 4 on top. Okay, if I want to take this one bigger one, or let's take this bigger cluster. And if I want to view the scatter plot for that, you see the number of points has increased. The same way, every time you change the values in the clustering here, so the scatter plots get updated. Okay, so this is the scatter plot for that particular thing. Okay, now this is how it is clustered. Fine. So by this way, you can understand how the values are grouped, how they are subgrouped, how they are even grouped. Okay. As you could see, like this is the first small group we have, and these two together makes a subgroup. This along with this makes another subgroup. And going further, we have several subgroups. Okay. So this hierarchical clustering is basically for understanding how the data are grouped. Okay, again, I tell you, if you could work on this example with any student's database, that would be more easy to infer, easy to understand. Okay, maybe if most of you didn't understand what a iris data set in the first place, then this might not make much sense to you. Okay, but just understand what these widgets are, because that's what the ultimate aim is. You have to know where and when to use which widget. If you get to know that, then you can master the orange tool. Okay, as usual, this file and data table. Now, in case of clustering, we have used these two additional things. So whenever you need to do some kind of clustering, we would need the distance to calculate the distance between each clusters and then plot it using a clustering. Of course, you have other types as well. For here, we have taken hierarchical clustering. Okay. So this is what this exercise is on hierarchical clustering. So any questions you could quickly ask me, else we'll move to the next exercise. After the end of the session, I'll put all these worksheets in Google Drive and I'll share the link with you. So if you have time, you can start working out right away, so that if you have any questions, you could ask me in the next session. Okay, so if you have if you have to do any projects for any courses, then this is what most of the even final year students are pretty much doing. Like they take a small data set, they perform some kind of clustering or some kind of classification, and they tell the results. This is not a really tough task, right? In fact, like without any coding knowledge, if you could do the project in 5 minutes, then that's really a good thing. But I wouldn't encourage that. You need to understand at least what distance means, what hierarchical clustering means, at least. Okay, because that's the ultimate motive of learning engineering. So if you don't understand what each algorithms are, then there's no use. Okay, but then if you understand that, and if you don't have time to complete a project, then you could use this kind of codeless tools to finish off the projects. Okay, in this particular exercise, we saw how to cluster an iris data set. Let's consider the cases of our capstone projects. Okay, like where people take one particular data set, they implement that data set with 2 3 algorithms, and they say which of the algorithms is the best. That's what most of the final year students are submitting as a projects. So we'll see one example on that. Okay, so the next exercise is on comparing 2 3 algorithms on a given data set. Okay, so we'll close the previous one. Fine. So for this particular example, again, let's take the iris data set. So going to that, let's load the iris data set. Okay, the file is already loaded in iris data set. As you could see, sepal length, width, petal length, everything. Okay. Now, the second step, of course, every time we do is like viewing the data using the data table. So data table, click on that, the data set, you could view it here. Okay, by now, at least these two steps should be by hearted. Like every time we start with file, every time the next step we do is like viewing the data table. Okay, so that's a common steps that we do every time. Now, let's understand what's the performance of this particular data set. Okay, to understand the values or the performance of this data set, we have a widget called test and score. Okay, this particular widget will tell you what is the performance of this particular data set. Okay, what is the accuracy of the data set, what is the precision, recall, AUC, and lot more. Okay, so what we do is we connect the file with the test and score, and then we click. You could see the model has not produced any values yet. The model name is not given, accuracy is not given, CA, F1, precision recall. So these are the different values by which you evaluate your model. Okay. So the main thing that we have to do is start implementing the algorithms. Okay. For now, let's take the first algorithm as a simple logistic regression. So click on logistic regression. So, and now connect the logistic regression with the test code. Okay, you see that the model has been learned right now. And when you click on that, on the iris data set, the model has produced, the logistic regression has produced an accuracy of 95% CA. CA stands for classification accuracy. F1 value 95, precision 95, recall 95, AUC area under curve is like 99, which is really good number. Okay, so we just trained our iris data set on the first algorithm, logistic regression, in 1 second. Okay, it's done. Now, as you see the values here, you could see that the model has not achieved 100% accuracy. There are some places where the model has misclassified, right? Because the accuracy is only 95.7. So if you want to understand where the model has failed, you have another widget for that called as confusion matrix. Okay. So this confusion matrix will tell you which all classes are positively classified, which are like wrongly classified. Okay. When you click on that, so you see this is the confusion matrix of the data set. If you want to make sense of this, click on the select correct option. So you see at the bottom now, select correct. When you click on that, all the highlighted ash colors, 200, 185 and 189. I mean, Setosa 200 samples are correctly classified. Versicolor 185 samples are correctly classified. Virginica 189 samples are correctly classified. If you want to see the misclassifications, I mean incorrect ones, click on the misclassified. As you could see, like there's 115 here, which is misclassified. There is 111 here, which is misclassified. Okay, which means around 15 of the versicolor. You see this, no? Actually, the given flower was versicolor, but it was incorrectly predicted as virginica. Okay, so 15 versicolor species were incorrectly detected as virginica. Fine. The same way, the actual one is virginica. 11 of the virginica species were incorrectly predicted as versicolor. So these two are the places where the model has failed. The rest all places where it is 0 means it has properly classified. Okay, so let's see the samples for that maybe. So, okay, before that, okay, so that's the confusion matrix. And again, when you want to view it as a data table, click on that and then now you could understand. Okay, so going there, if you want to understand what are the 15 data that were incorrectly classified, click on that 15 and now your data set would get reflected. Okay, so these are the 15 species of versicolor which was incorrectly detected as virginica. These 15 samples were incorrectly predicted. Okay, the same way if you want to understand that 11 which were incorrectly classified, click on the 11 and then you could see the changes here. Okay, so these 11 species of virginica were incorrectly classified as versicolor species. Okay, so these are the misclassifications. So to do that, what we did, we created the confusion matrix and then we connected with the data table. Okay, with if you don't select it with the confusion matrix, so where is the confusion matrix? Okay, if you don't select anything, then your data table is going to be empty, as like here. Okay, if you want to have some values in that, then what you have to do is like you have to click on the particular thing you want to understand. If you want to understand the 200 values that's properly classified, click on that 200 and these are the 200 values that were properly predicted. Okay, the same way if you click on anything, it will tell you as which one was that. Okay, this is how you actually understand one data set. Okay, the same thing you can see it with scatter plot as usual. Okay, so this is a scatter plot. And again, every time you have to go to the confusion matrix and see that. Okay, now I'm selecting on the 15 incorrect classifications. Okay, this was that. Again, every time if you want to make it meaningful, click on the informative projections and then you could see different options like different options of regression, petal length. These things you can view. Okay. Now, since the misclassifications are very low, like this doesn't make any sense because it was just 15. Okay, if not, if it will give you very meaningful data from that. Okay, fine. So this is how you actually evaluate your data set on one one algorithm. Okay, all that we did was like created a data file on iris dataset, viewed the dataset as usual, and then we evaluated the algorithm logistic regression using this dataset. As you could see, logistic regression has produced an accuracy of 99, 95, 95, 95, 97, something. Okay, a very good accuracy. This is the test values, the score values, the performance metrics. Now, when you do the project, all that you will do is copy these numbers into a table and then say logistic regression produced an accuracy of 95.7, precision of 95.7, and so much more. And to put the confusion matrix, you can just snip this and put this is the confusion matrix of my data. And the same thing, if you want to plot only the confusion matrix, I mean the scatter plot for the misclassifications, you can click on that and then plot this chart. Okay, so this is how you do it for one algorithm. Okay, now we have trained and tested our model on one particular algorithm called logistic regression. If you want to do the same thing with a different algorithm, choose your own algorithm and then do the same thing. Okay, now for simplicity, I'm going to take a random forest algorithm. Okay, so random forest, same step repeats. Okay, all that you have to do is connect the random forest with the test and score. The model got learned. Okay, so you could see here learner, model got learned. When you click on the test score now, you could see the values of random forest as well as the values of logistic regression. Okay, if you don't want to see the values of logistic regression, you could simply click on this and then click delete. Okay, now the logistic regression is not connected to the model, only the random forest is connected. Now, when you click on the test and score, only the random forest comes. Okay, but for comparison, let's keep this logistic regression as well. So I'm connecting it. Okay, so now my model, I mean my data set, iris data set is trained on two different algorithms called logistic regression and random forest. Now, all that I'm going to do is compare for the given iris data set, which algorithm is the best. So simple, right? So I'm going to click on test and score and then see which one has got the best performance. Okay, so as you could see, in terms of classification accuracy, logistic regression has got higher accuracy of 95.7, wherein random forest has got only 94.7. The same way with respect to all other factors, logistic regression seems to be the best choice for iris dataset in comparison with random forest algorithm. So simple conclusion. Okay. So if you could do this for the rest all algorithms, like 4-5 algorithms, and that's what pretty much your capstone project looks like. Okay. Without no coding. Fine. So the same way you can use the confusion matrix as well. So where's the confusion matrix? Okay, so this is the confusion matrix of random forest as given here. And the next one is logistic regression. Okay, as you could see, random forest has got even badder results like 18, 14 misclassification, whereas logistic regression has got only 11 and 15 misclassifications. Fine. The same way, when you click on the data table and you can view it, you can view the scatter plots, everything. Fine. So this is how you take one data set and then train and test your model on multiple algorithms and make a comparative study stating for the given data set which of the algorithm is the best choice. Okay, so this is the third exercise I think we are doing. Okay, any quick doubts in this? Please feel free to ask me. Okay, comparing algorithms on a single data set. Okay, any questions? Abdul, can I do project on this? Of course, you can do it. Like for certain students, like when people are doing something on data analysis, data analytics, you can very well use this projects and all. But I'm sure that your faculty, unless and until your faculty questions on what kind of programming language you use, there is no problem. Okay. If you want to finish off your project in less than 10 minutes, then you can use this orange tool. Okay. Or if you want to really learn the programming languages and do things, we do have sessions coming back. Okay, so but this today's session is on codeless data science, where we do projects without using a single line of code. Fine. So this one is on comparing the different data sets. Okay, so moving on to the next one, let's do it on k-means clustering. Okay, right now the previous exercise we saw it on hierarchical clustering. how to cluster. The next one we'll be seeing is k-means clustering. Okay. Okay, so now we'll see a very different option that we haven't seen till now. What's all this? Fine. So all this time we were loading the data set using the file option. We either went and browsed the data set or we used the Google Sheets link to load the data set. But right now, let's create our own data set, or in other terms, I should say it as let's paint our own data set. So an option that you have for that is paint data. Okay, so you could see here paint data. So click on the paint data and you can create your own data set. As I told you, this exercise is about k-means clustering, where given a data set, you need to cluster it, okay, on some basis. Fine. So let me create my data set. You have several options to create it. As you could see, there's one plus some symbol here, put. So if you click on that, every time you'll have to give tick, 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 and then you have to click, give your data set. Okay, bit tedious, na? So let's take the brush option instead. So click on the brush, and when you click on one option, one place, the data set gets generated. Okay, and let me click on another place, another data set. Let me give a third data set, third cluster. Okay. So this is what my data set now is. Okay. I have got some random numbers like 166 different datas I have, and they have been clustered very neatly. Like, at the end, it's about grouping. On what basis you group? You know that this particular thing, like this particular thing is on like one, sorry, this particular thing is closely cluttered. So this belongs to group one, this is group two, and this is group three. Okay, that's how you can say this is group one, and this is group two, and this is group three, because they are like closely related. When you calculate the distance, then this becomes the group one, group two, and group three, right? So this is how I have painted my data set. Okay, now what I'm going to do is I'm going to use k-means clustering in this. Okay, and then see how many clusters, how many groups does my data set have. Okay, so you see this k-means. Okay, now let me fix it like, like I created the data set. So I literally know that I have three different clusters. So let's fix it as three different clusters here. Okay, so on the other hand, if you don't know, like if and all, if your data set is really big, like assume that there's other different ways as well. Okay, this is one other way, and this is one other data, this is one other data. And if and all, if your data is going to be really big and it is really complicated for you to count it, then in that case, how do you calculate the number of clusters? Okay, so this big data set, click on the k-means. If you don't know, you just give it as from. Okay, and then you tell how many clusters it could be. Like if you just tell the range alone, it could be somewhere in the range of 2 to, let's increase it to 10. Okay, or 2 to 20. If you don't know, give it a maximum number, no issues at all. Okay, now you could see that if and all, if you say that your data has just two clusters, then the score is like 45%, which is really bad. Okay, if you say that your data has seven clusters, which is highlighted here, you see the score is around 75%, which is the highest. You could see down as well. Okay, it doesn't mean that when you increase the number of clusters, the accuracy is going to increase. You could see when you consider it as 16 clusters, the accuracy is 38, which is really poor. So the proper number for the given data set is, the proper number of clusters for the given data set is 7. Okay, so this is how, given a data set, you can identify how many clusters are there. Okay, so if you give a student's data set, right from register number to CGPA to maybe the place he is coming from, day scholar or hostel, and so much more. Assume you have collected 50 details from each of the student, and you have a student data set of 50 different students. When you give this, and if you want to understand on what basis these students are clustered, okay, where on what basis they are grouped, you just give the data set, give it as k-means, give the range alone. From what range? Of course, if it is a group, means it should be minimum 2. If it is 1, then it is not a group at all. So a group should start with a minimum number of 2, and it can go to any number. Okay, let's fix it as 20 or 25, and then you will see like the 500 students are clustered based on 7 different groups. Okay, that's how you can identify the groups in a particular data set. Okay, let's consider one data set, like let's consider it on a bigger data set this time, because iris data set, it has just 3 clusters. versicolor, setosa, and virginica. So let's take a different data set that we don't know. Maybe the housing data set. Okay. So these are the different features we have. CRIM, ZN, Indus, CHARS, NOx doesn't make any sense. Okay. But then you know that we have around 14 different features. Okay. 14 different features we have. 506 instances, I mean 506 rows, and there's no meta values and no meta missing values and all. Okay. Now this is the data set we have. As usual, what we do is we plot it using the k-means. Okay. So now you click on the k-means and then you fix the ranges 2 to 8, and then you see this particular data set has a, I mean, the best of the cluster value is 2. Okay. So this particular data set, housing data set, can be grouped into just 2 classes. Okay. That's what the meaning here is. Fine. So one other thing I want to tell you is, let's take another example of paint data only. Okay, so paint data, and then I'm going to paint my data set. This time, let's paint it in a different way. Okay, this is the eye. Okay, this is right side eye, and this is the mouth. Okay, so I assume that this looks like a smiley face. Okay, so this is a smiley face that I've given. So this is group 1, group 2, and group 3. Okay, let's see how this k-means is identifying the number of clusters there. Okay, so here is the k-means. So as you could see, when we fix the range of 2 to 4, it has given me a cluster of 4, which means it says the given data set can be clustered into 4 different groups. But as you could see, it's so obvious that I have, this is group 1, this is group 2, and this whole thing is my group 3. You know it, right? This is my smiley face. So this should be just 3 things. However, our k-means have told that it has 4 different groups. Where is the 4th group? Okay, so this is the drawback of k-means algorithm. Okay, unless and until you give it in a spherical format, like as we did in the first time, no, this case, where the data set is like clear, really clear. Okay, when there is a clear distinction, k-means works perfect. On the other hand, when you try to give some certain shapes or spheres or something like that, then k-means doesn't work good. Okay, so this is the drawback with k-means clustering. Okay, and this is not the fault of orange tool. This is the problem with k-means algorithm in the first place. Okay, so this is all about the k-means clustering. Okay, so we in this exercise we learned as how to paint a data, where you can click on the paint data option and then you can start painting it here. Okay, so use the brush icon here so that you can generate the data set over there, or if you want you can use the plus icon as well to put the data set. Okay, if you want to put it this way, but this is really tedious, so I would suggest you to use the brush icon. Okay, brush, and then the data set gets generated there. Okay, and if you want to understand now itself, you can't count as how many data clusters you have: 1 2 3 4 5 6 7 8 9. So when it becomes tedious to understand the number of clusters, just give k-means and then it will tell you how many clusters does this particular data set have. Now that I have increased 2 more clusters, my cluster group is 9. Okay, so this is how you do it. And this is, if you want to understand it with respect to a data set, simple: load the data set, housing data set, and then give k-means. Okay, just 2 steps. By this way, you can understand the clustering of your data set. Okay, the same thing you can work out with different examples, like take a very good bigger animal data set. Okay, and then have different classes like domestic animals, wild animals, different classes. But then give the k-means and let's see how it is clustering. Okay, so if you have 10 different animal species, then you should have a cluster of 10. If not, the k-means isn't really working good. Okay, so this is the next exercise. It's on k-means. So any quick doubts, please ask me. You can please post your messages in the chat so that I can clarify it. Okay, so enough of all the boring exercises. So we'll go and we'll finish off with one very interesting application on images. Okay, all these times we were seeing applications related to Excel sheet, tab, text sheets, Google Sheets, all boring text applications. But right now let's focus on one image based applications. Okay, so in fact, if you have something related to bigger images, then you could really say it as a bigger capstone project, of course. Okay. Instead of showing a one Excel sheet and saying this is my data sheet and this is my data set, if you could show a bigger folder containing different images and you're making some analysis out of it, then that's what really a bigger project represents. Okay. So we'll see it in terms of image based application right now. Okay. So okay, so we'll do two exercise on images, and with that we'll wind this today's session. So before starting, let me tell you what is the data set first of all. Okay, so where is the data set? Okay, so here's the first data set, a very simple one because I don't want to take much time on training part. So I've taken a very least number of just 15 images. Okay, we have the animal data set here. The first one is cat, cow, dogs. Okay, and each I have just five samples. These are the cat images, cow images, and the dog images that I have. Okay, so these are the three different data sets that I have. Now we are going to understand how the image analytics is. Okay, like we are going to try to understand the classification part here. Okay, how the cat is classified from cow, how the cow is classified from the dog, how they're differentiated. We'll see that part. Okay, so now unless and until sorry, like all this time we had been talking about loading the data set using the file option. But as I told you, file option is explicitly only for Excel sheets, text files, CSV, tab files. And if you want to create your own data, you have to use the paint data. And if you want to import images, then you have the option called import images. Okay, this option. But before that, you have to go to options, click on add-ons, click on the image analytics, install it, reopen the orange tool and then start working. Okay, I already installed this image analytics. That's why I'm skipping that step. If not, if you click on this import images, this option will not show. Okay, this will not be enabled unless and until you click on that add-on image analytics and then install it. Okay, so don't forget, go to the options, click on add-ons and then click on the image analytics, install it, restart the orange tool, and then only you can find this import images widget. Okay, so now click on the import images and then you have to click on the folder where your data set is located. As I told you, we'll be working on the animal data set now. So click on the whole data set and then select it as a folder. Okay, so as you could see, we have 15 different images belonging to three categories, which is nothing but the cat, cow, and the dog. Okay, so this is how the data set is now. And every time what we would do, we would go to the file option and then view the table. File option, view the table. This time we have loaded the images and then we are going to view the images. So the option we have is image viewer. Okay, so this is the option to view the images you have. So click on the image viewer and you could see all the 15 images that we have. Okay, so these are the 15 images. Cat, as you could see, the cat represents the folder name and c1.jpg represents the file name. Okay, similarly, dog folder, cow folder, dog folder. Okay, all the 15 images are right here. Okay, now let's see the test and score. I mean, what we'll do now, we'll just see what is the performance of this particular data set. Okay. On other hand, okay. Let me explain you this. Okay, like this particular step, we have viewed all the images, right? And if you want to understand the images in with respect to a table, as usual, every time go to the data table and then connect it. And as you could see, are you going to view the table only for the selected images or for the whole data set? Let's check it out for the whole data set. So click on this, and then when you click on the selected images, it goes off. Okay. When you re-click on the line, it goes off. Okay. What I'm going to do is I'm going to view the table for the entire data set. So data to data, click OK. Now the data table, you can visualize it. Fine. You see the category is cat, cow and dog. The file name is C1, M1, D1. The folder location is this, the size of the image, the width, height with respect to pixels, and is the image selected or not. No, we didn't select any image, so it comes out to be no. Okay, so this is the details that we got out of the images. And with this table, will it be enough for you to classify a cat, cow, dog? Hardly, right? Because we don't have any features with respect to a files. I mean, the images actually, the animals. Every features that we have, the size, the width, the height are representing the images. Okay, the size of that particular image, the width of the particular image, and height of the particular image. How could you even classify the three different classes with these features alone? These are not enough, right? So what we'll do is we'll create an image embedding. Okay, so this is image embedding, the next option. Fine. So this image embedding is, it's basically to create a vector representation of the images in your data table. Okay. So vector means what, you know it, right? Like when you want to convert that images, which is in a pictorial format, into a tabular format. Okay. You want to understand certain features and you want to put that numbers in some values. At the end, everything revolves around values only. Okay. So that is what the image embedding is, converting your image, which is in a pictorial format, into a vector table format, okay, into a numerical format, okay, so that you can get some features out of it. Fine. So this is the image embedding. So what we'll do is we'll connect this, let's move it here. And for all the images that is showing in image viewer, let's create the image embedding. Okay, so for all the images, so it's data to data for all the images. Or if you give the first option, it will give you the image embedding only for the selected option. We cannot go and select each and individual image every time. So let's give it as data to data. Okay, so now the image embedding is created. Now click on the image embedding. Okay, I'll tell you that a bit later. Now to view the data table again, now you could see that in the earlier case, we had only these features, right? We had only the image name, file location, size, width, height, and selected or not. But right now you could see there's so much more other details that is gathered from the given images. So much more. How much? 2048 features. As you could see on the top left, the instances says for the given 15 different images, we have around 2048 features with three different classes. So these many features we have got. Although we don't understand what that particular feature is because it is given in terms of numbers N409, N4101, 411, 12, 13. Although it's given this way, but you could understand that earlier we had just 5 features, all useless features. But right now we have a very solid 2048 features for the given 15 images. That's really a big number, right? So this is how you can create a meaningful information out of the given images. Okay. So image embedding is the concept that is required for converting your image into a vector representation. And this is what I mean by a vector representation. This. Okay. Fine. So now what is the algorithm that is used in the image embedding? This is where you can do a comparative study. Okay, click on the image embedding, and as you could see, first technique that we have used as an embedder is inception v3. Okay, so this particular thing I think most of you might not understand because most of you are like first years. So inception v3 is a kind of neural network, and we have other several types of neural networks as well. Okay, so assume you have a very big network, very big data set. Okay, we had a data set called as ImageNet, which had so many millions and millions of images. Okay, on that data set, this particular inception v3 network was trained. Okay, so this inception v3 has seen around 1 million image samples. Our particular data set has only 15 samples. So when you try to learn it with only 15 samples, it's not so easy to classify, right? Because you can hardly understand how a cat is different from a dog with 15 samples. You need more and more samples. Okay, this particular example we know how a cat and dog looks like, but assume in case of the same diseases and all. Okay, assume the cases of a monkeypox and some other pox. How do you classify it? Because we don't know, we are not medical students, we don't know how it's going to be different. So in that case, only when you start learning more and more examples, you will be able to better clearly differentiate how a monkeypox is different from a donkeypox. Okay, so that's how that's how it works. You need lot and lot of samples to understand the basic differences. Okay, so we had just 15 images, which is not enough for a model to understand how a cat is different from dog. So we use embedders. Right now, I was talking about Inception v3, which is actually trained on 1 million images. Okay, so which is really a good number. So if the model was trained on 1 million images, this 15 is like nothing to it. Okay, the same way you have other data, other embedders as well, like you have VGG16, okay, and you have VGG19. All these are different neural networks. Okay, we have one session coming up like in next week where they'll discuss about the different neural networks and all. For those who don't know what neural networks are, please attend that session to understand what this is actually. Okay, so we have different types of embedders available. Every time when you change the embedding, your data table will differ. Okay, your data table will differ in this way. Okay, for simplicity, right now, let's take the first one, Inception V3 network alone. Okay, so this is the Inception V3 we have. Again, now we have embedded the data, we have viewed the data. Now let's see the performance of the data. Okay, let's see it in terms of test and score as usual. Click on the test and score and connect it with the image embedding. Click on the testing score. Okay. So as you could see, there is no values because why? Because the model has not been trained on any algorithm. Okay. So although we just created a representation, vector representation, we haven't used any algorithm to train on the data set. For the 15 images, we need to train it using any algorithm. Let's take the simple logistic regression again. So click on the logistic regression and then connect it with the test and score. It's getting trained, as you could see. Now, this is where I want you to please take note of. For the 15 images, if it's taking 1 minute to train, imagine the cases of data sets with at least 10,000 images. Okay, so orange is very easy, but again, the training time depends on your system configuration. Okay, now click on the test and score. Now you see, wow, that's really a very good number. The logistic regression has achieved an 100% accuracy on all cases. Okay, so this is what the performance of our model is. And now, of course, if you want to view it in terms of confusion matrix, although we don't have any negative classification, but for namesake, let's see it with confusion matrix. And as you could see, everything is properly classified. There is all zeros. Misclassified is like nothing, 000 only. Okay, that's really a good thing. Okay, now let's take the case of another embedding. Now we saw it with Inception V3. Now click on the embedder again and click on VGG16. Okay, now the model is again getting trained. So 9%, 19. So it's getting trained actually. The same way you can put a tabular column and then put for the given 15 images, the values, the performance of Inception V3, the performance of VGG16, VGG19, and lot many embedders that you have got. You can put everything in a table and you can make a very grand comparative study. Okay, now let's click on the test and score and see. For the same logistic regression, when you use the VGG16 embedder, the accuracy has dropped down by 1%. Okay, and the classification accuracy has dropped down by 4%. So, which shows that for the given 15 images, Inception V3 is much better than VGG16. Okay, that's the kind of inference you make out of this. Fine. So this is with respect to the embedders. You can otherwise check with other different algorithms as well. Okay. And one other thing that you could do is, of course, train with a very different algorithm. Okay, let's take another algorithm, as usual, the random forest. Okay, now click on the random forest and then as usual, connect it with the test and score and your model is getting trained. Now you will have a comparative study of how the model has performed with respect to logistic regression and how it has performed with random forest. Okay, both comparisons we can have. And again, every time you can change the embedder here now to Inception V3 again, and then you can see which one is producing better results. Okay, a very detailed comparative study you can make and then say for the given data set, this model is the best, this is the worst, this is the choice, everything you can make. Okay, now click on the test and score, and as you could see, of course, a logistic regression seems to be a better choice than random forest. Random forest has like bit poorer accuracy, like it's just for 61%. Okay, so let's not take it up. Maybe if we change the embedding, we can have a better results. Okay, this time we have changed the embedding to Inception V3, and then you can see. Every time your model's performance final results depends 99% on the data set. If you have had very bigger data set, then your model would have produced even better results. Okay. Now, since we have just 15 images, the results are not up to the mark. Okay. Now click on the test and score again. And as you could see, this time logistic regression in combination with Inception V3 has got 100% results and random forest has got 68.3 results. Okay. Now let's click on the confusion matrix and then see the performance of random forest. Okay. I've clicked on random forest and then I've seen that, okay, some 4% of dogs are actually predicted as cat. Okay, that's something weird. So what we'll do is we have selected that in the confusion matrix. Okay, I've clicked on this 4 misclassifications. Now I want to view it pictorially. What I have to do is click on image viewer and then connect it. Now click on image viewer. So these are the 4 different dogs that were actually misclassified as cats. Okay, fine. That was really bad prediction. Okay, so these were the misclassifications. The same way, if you want to view some other things, okay, there's some 9 dog images. Okay, sorry, not that one. This one. Uh, okay, we'll take this 7. Now, some of the dog images were actually misclassified as cows. Dogs were classified as cows. What are those? These samples were actually detected as predicted as cows. That's again really weird. Okay, so this is all, this bad performance is all because of the number of images that we actually put in. Okay, since we put only 15 images, the model was not able to understand how a cat is different from dog and how is it different from cow. That's why we have this bad results and all. Okay, so this is how you do the image analytics with respect to classification. Okay, so let me tell you once again. Unlike the previous cases, this time we are going to load a data set of images. So we need the option called import images. Click on import images, load the data set and then load it as an entire folder, animal data set. Okay, load it and then you can view it using the image viewer, all the 15 images. And if you want to understand how the data is, how the images is, just click on the data table. As you could see, no meaningful information to make any proper classification. Just with the images location, images size, images width and height, you cannot classify cow versus dog versus cat. That's really like, that's weird. Okay, so what we have to do is we have to convert the given images into a vector representation using an image embedding technique, which follows multiple algorithms. We have Inception V3, VGG, and lot more. Click on any one of your favorite embedder and then click OK. The model gets trained. And when you click on the data table again, now it will show you additional features. These features are all with respect to Inception V3 that we chose. Okay, now from 6, we have got 2048 features, which is really huge. Now we have to start testing this embedder on different algorithms. Okay, we take the 2 sample algorithms, logistic regression and random forest. To view the performance, we have this widget called test and score. Click on that and you get the values of both random forest and logistic regression. Okay, and then if you want to know where the model has failed, like random forest has got only 68% results. And if you want to know where the model has failed, click on the confusion matrix and you could click on select misclassified and it would show you all the ash color boxes as misclassified. You could see that there is 7 misclassifications in case of dog versus cow. Okay. And if you want to view the samples, you can click on image viewer and it will tell you all the samples that were actually misclassified. Fine. So this is how you can do the classification. Now, start thinking of any particular data set. Like not only animals, you have several other data sets, even related to medical applications. You have this brain tumor classes and so much more. Download one data set, load it, test it with different algorithms and make it as a project. This is more than enough for like a beginner level. Okay, fine. So any quick doubts here? Okay. Anything in the chat? Again, Meghna, one second. Yes, Meghna, please ask your question.
Ma'am, in case of misclassified, if we get the more number of misclassified images, then we have to select other algorithm for the correct one, ma'am.
As I told you, like the misclassification does not only depend on the algorithm, it's predominantly on the data set. First of all, data set is the primary factor deciding your misclassifications. Let's take it in a simple case. Assume that we have a very little baby and we want to teach the baby how is a cat different from a dog. Okay, simple dog versus cat classifier. If you're going to show the baby some 5 images of dog and 5 images of cat, and then you say them that this is how a cat looks like, this is how a dog looks like, and when you show them a random image and ask him to guess, the baby might not guess it correctly, right? Because the baby has hardly seen only 5 images of dog and 5 images of cat. And of course, the dogs could come in different colors, different sizes, different breeds. There's lot much more. So the more and more samples you show it to the baby, like when you show like around 1,000 images of a dog versus 1,000 images of a cat, by that time the baby will be better able to classify a dog versus dog cat, right? The same thing goes with the data science projects as well. The more and more samples you have, the bigger your data set is, the model will be able to understand better. Okay, now in the given data set, our model is trying to learn how a dog is different from cat only from this 5 images. You see, like this 5, and from this 5 you could see that the first thing that the algorithm will learn is the color. And as you could see, the cat comes in brown color, white color, black color, and some chocolate color, something. And the same thing when you go to the next dog case, and as you could see, the same white color comes for dogs as well. Same brown color comes for dogs as well. So this is the first place where your model gets confused. So it will start learning other features. It will start learning some other features. Maybe let's take the case of a ear. Okay, dogs have this kind of ear. And take the case of cat. The cats have some pointed ears. Fine, that's totally different. And consider the case of a cow. The cow has some other different types of ears. And this is how they will start learning the features. Okay, now when you give only 5 samples, they will be not able to learn much features. Assume 10 to 12 features. But when you give millions and millions of samples, at least lakhs, at least thousands of samples, they will learn much better features. And then even if you take a very trivial, very simple algorithm, the model will perform better. Okay, so the end point that I'm saying is the model's performance, first of all, purely depends on the data set. What type of data set that you have, what kind of data set, and how much images that you have. If you have a really decent number and if still the model is getting bad results, it means the algorithm is not a good choice. As we saw, for the same 15 images, random forest has bought very bad accuracy, wherein logistic regression was able to achieve 100% accuracy. That's really a good number, right? So the first thing depends on the data set size, because here we trained with 2 algorithms. If logistic regression was able to perform with 15 images, random forest should also be able to perform, but it was not the case, right? So that's how you have to think. But as I tell you, data set is the first option that you have to work on. Okay, if you have very small data set, try to increase the number of images and then rerun on the same algorithm. If the accuracy seems to improve, then that's a good choice. If not, then you have to keep trying with number of images higher, higher, higher until you achieve a better accuracy. Okay, Meghna?
Okay, ma'am. So for the 100% result, we have to see the logical aggregation, and all the others we have to check for the 100% result.
No, like as it's like a standard term, never ever any project or any real-time project or beat this also. Like this is really a very surprise that this model has got a 100%. Else the case is never 100%. Okay, even if you get 99.98, yeah, you can just take it as the maximum. Okay, as you could see, like in the image embedder, when you change from inception V3 to VG16, even the logistic regressions performance goes down a
1% is
bit.
different, ma'am.
Yeah,
Yes.
right. So again, every choices you have to check. No, no, when you try with different choices, that's what is called as tuning your model. Okay, trying with increasing the number of images, trying with changing the embedded algorithm, changing the type of algorithm. Yeah, by that you have to tune your model.
Okay, ma'am.
Okay.
Thank you.
Yeah. Any other question? Anyone else? Okay, then give me 5 minutes time. We'll just finish off with one last exercise. That is again related to images only. Okay, so in the previous case, what we did was like we took animal data set, we classified them into three classes: cat, cow, dog. We put the samples. Right now, we are going to take the case of domestic animals alone. Okay, and you could see that I have some 17 samples in that. Domestic animals I have taken 17 images only, and with this I'm going to trying to group them on certain basis. Okay, if I give the 17 samples, let's say one particular algorithm, and let's see how they are grouping. Okay, one meaningful grouping should be in terms of maybe animals together, birds together, because as you could see, we have buffalo, calf, cat, cow, dogs, and all, which belongs to animals. And we have chicks, duck, goose, hen, which all belongs to birds. Okay. So the first meaningful grouping could be animals versus birds. Okay. But let's see how the model is actually doing the grouping part. Okay. So as usual, as you could see, this is an images. So we have to use the import images widget. So click on import images and then load your data set. The data set is domestic animals, select folder. As you see, 17 images are already loaded. In the previous case, it showed us the number of classes like cat, cow, dog. It showed three classes. But right now, since we don't have any classifications, it just tells we have 17 images. Okay. Now, after that, of course, you want to view the number of images you have here. So go to the image viewer and then click on that. Okay. Now you could see these are the 17 images that we have here. Okay. And of course, if you want to view the images in terms of data table, you click on that and then give entire data. Okay. For the entire data, you want to view the table. What it would you give? It would give no meaningful information. It's giving only the size of the image, width of the image, height of the image, location of the image, name of the image. That's it. Okay. This is all useless information. And with this, we cannot classify the birds versus animals. Okay. So what we are going to do, we need some perfect image embedding as usual the last time. Okay. We're going to use the image embedding here and then connect it with the list of images we have. Okay, and as you could see, we have different options in the embedder, but let's take the Inception V3 only because last time we saw VGG16 is not as good as Inception. So let's fix it as Inception. And then now we are going to talk about the clustering part. Okay, which means how these images are clustered. So if you could recall the second exercise that we discussed, whenever you want to talk about the grouping, the first thing that has to come to your mind is the distance. Okay, we need to calculate the distance between each samples. Fine. So click on the distance and then connect it with the image embedding. Okay, fine. Okay, so next is, of course, after following the distance, you need to make some meaningful clustering algorithm. So clustering algorithm is hierarchical clustering. This is similar. These two steps are similar to the ones that we already discussed. Whenever you want to perform clustering, the two steps are like distances followed by the hierarchical clustering. Okay, so click on the hierarchical clustering and you could see this is how the data is connected. Okay, how unfortunately the numbers are given, the names are not given, instead the numbers are given. But let's see the samples as how is it. Okay, let's take this last clustering. There's some two animals. One animal is 10, one animal is 15. Let's see how they have clustered and let's see if the clustering is meaningful or not. So of course you need to connect it with the image viewer and then you have to view it using the image viewer. Okay, now click on the image viewer and these two are the animals. Voila, we have got it right. Somehow it has correctly grouped two different birds as one group. Okay, so this is the group we have. Okay, let's go back and see some other group and let's see if it has grouped it properly or not. So, okay, let's check this one other group, 4 and 9, and let's see what that particular sample is. Okay, again, two birds are grouped properly. Okay, we'll see one other sample. This sample we'll take 2 and 13. Again, a cow and a buffalo. Okay, it's really good. Maybe we'll take a bigger one. Okay, this time. 5, 12, 2, and 13. Let's see how they are grouped. Wow, all the classes of cow. A cow, a calf, a buffalo, and a ox. Everything belongs to group cow. Okay, like they all belong to one group, right? So really good. Like with 17 images, we were able to make some meaningful grouping. We'll take some other sample. I'm waiting for any one negative sample. Okay, let's take this grouping, a bigger one. Okay, and let's see what that is. Okay, fine. And all the animals, some way it has grouped all the animals. Maybe let's take this group, not this. Okay, we'll take. Okay, let's take this group and then see what it is. Okay, and all the birds are grouped perfectly. So nice. Okay, so many meaningful groups. Okay, this one I don't know. Okay, see, I took a very big subgroups. So it has not got a proper result. So this subgroup will give me all the animals. Okay, so when you click on the subgroups, as you could see, you will get better results. Okay, maybe we'll club this and this. Okay, it has taken both birds and animals. I don't know on what basis it has grouped, but something it has grouped. Fine. So this is what the clustering is. Okay, so what we have done here is the same as usual. Imported the images, viewed it, nothing useful, make some embedding using some proper algorithm. And then since we are talking about clustering, we need to use the distances and hierarchical clustering algorithms. Okay, and cluster it and then start viewing the images. So your actual results falls in this hierarchical clustering widget. Okay, so when you click on a particular thing, you will get as what cluster it belongs to. Fine. So this is how you will perform clustering with image analytics. Okay, so this is the last exercise for the day. So with this, I'll stop it right here. So any doubts in the whole thing, you could ask me right now. All the workspace along with the data sets, I'll put it in the group tonight. I'll put it in the Google Drive. So please go through that and then let me know if you have any doubts. Okay. And guys, like this orange is really a very big tool. Like although this might look a very simple tool, but you know, you could do so much and so much with this. Okay. Like I tried to cover the maximum that's possible. I had even prepared for few other interesting topics, but unfortunately it's almost already 8. So let me not take much of your time. Maybe if we have time, we'll have one other session. We'll have one other session especially for orange. Okay, because you know, since you're like even for the capstone projects, we see people doing submitting projects in this level only. Okay, where they compare and they understand. Okay, while you're giving the review, maybe you need to explain how this algorithm works. But apart from that, for doing the project and for getting the results, this doesn't take much time, right? I think you would agree with me because it's codeless. Fine. So that's the one good advantage of this. So we have many other interesting applications. If we have time, I'll take one other session on Orange. If not, I'll share videos where I do the demos and I'll put it. Okay, maybe you can watch it over there. Fine. So any questions? Okay, this is a very big topic, Sushant, how image embeddings works to find features. So if I start talking about this, it's going to take a much of time. But in simple terms, it's it's about converting an image into a vector representation. Because when you see it as an image, you would agree that you cannot understand what its features are. But as I told you, when you see an image, you will talk about its color, its eye features, its nose, its location of the eye, how the eye is aligned with the nose, how nose is aligned with the mouth. Likewise, we have so much features. When you start representing the features in some numerical format, that's what the image embedding is. Okay. Maybe tonight I'll put one material on image embedding. I'll try to explain and I'll put, you can watch that. If not, on next session, maybe I'll tell you that. Okay. Any other questions? Maybe for now, I'll give the, yes, Meghna.
Ma'am, but for sure, it just differs for only cat, dog, and cow. If we take three different names, it only differs for the only three categories, no, ma'am. But not for cat to cat. Means we select different images for each category, no, ma'am. So
Yeah, that's why this is where we say it as a rich learning process. Okay, because it does not only compare the cat versus dog, but it also compares and understand how this cat is different from this cat. Because as you could see, these two cats, like, because as a human we would understand, but for a system level, which purely depends on colors, RGB values, the first thing that would change is cat brown and cat white. So it would think this as two different images. Then only it will start understanding the various other features. They would start comparing how its ear is and how this ear is, eyes, nose, mouth, everything. It would start comparing on a feature by feature basis, and then it will understand, okay, these two belongs to one particular class called cat. And then it would start comparing this with the next category called dog. Okay, so that way it, like, if it has to understand, because we would give samples like in black color, brown color, chocolate color, white color, and whatnot, every colors we would give. So it first has to understand and learn all the features of a particular class, then learn the class features of other class, then compare and understand how things vary. And all this is only is represented in terms of the where is that image embedding part. Okay, one second, data table.
So the comparison will be vectorized only for the cat, dog, and buffalo or some other categories, but
Yeah,
not the
whatever
same
you do.
category. Okay.
No, no. As you could see here, no, this N0 might represent one particular feature. This N1 is another feature, N2 another feature. That way, for a given cat image, they have taken like 2048 features. The same 2048 features was read for rabbit, for duck, for llama, for all other features as well. Okay, so they learn almost 2048 different features of this particular image. The same way they learn it for the rest all, and that's how they compare and then finalize that this is different from this. Okay. And in order to learn, you see, we have just 5 samples of cat. Okay. So they have this 5 into 2048 features. That's it. That is really so small. Although the number comes out to be big, but you understand, right? Like understanding with 5 features is totally different from 5 million features. So when you could provide more and more samples, and the same 2048 features only would be read. But by then, the system would be so confident, even if the cat shows up in this position, that position, the major drawback with objects is like you cannot say which you cannot say a standard thing, right? Like even if it is a cat, you could see this is in lying position, this is upright, in this tail is not shown, legs are not shown. So the animals would come up in different poses and it has to learn all the features. Right now we have just showed them with 5 different samples. If you could show with so many samples, then the model is sure to get good results. Okay.
Yes.
Yeah.
Thank you.
So I've enabled the mic for everyone. So any quick doubts, anyone can please ask me.